meaning we can increase or decrease the production of specific proteins, which play a role in the actual effects of the thyroid hormone. For the sake of time, in the next video we can discuss these effects. Now that we know how the thyroid is produced and how it actually functions within the cell, let's talk about some of the effects of the thyroid hormones. As a preamble, hyperthyroidism is the production of too much thyroid hormone, whereas hypothyroidism is an underactive thyroid leading to too little thyroid hormone. With that out of the way, one of the most pronounced and noticeable effects of the thyroid hormones is its control of our metabolic rate. An excess of thyroid hormones can up to double our resting metabolic expenditure, whereas a deficiency can cut our resting metabolic expenditure in half. The average female has a resting metabolic rate of 1,421 calories, meaning at the most extreme level, this can be cut to 710 calories in hypothyroidism, or be close to 3,000 calories in hyperthyroidism. The way that it does this is by increasing the size, number, and efficiency of the mitochondria, which are the small organelles within our body that break down molecules into energy. It also increases the production of enzymes within the respiratory chain, which are the actual enzymes within our mitochondria that facilitate the production of energy. Finally, we may see an increase in the production of sodium-potassium ATPases. These are small proteins that utilize ATP to exchange sodium and potassium between the bloodstream and inside of the cell. For the sake of this discussion, it's important to understand that these proteins account for between 15 and 40% of a cell's resting energy expenditure. Therefore, the way that thyroid increases our metabolic expenditure is by increasing the breakdown of fats, carbohydrates, and proteins, and increasing the cell's production and usage of energy. The final thing that it does for our metabolic expenditure is to increase the production of specific proteins called uncoupling proteins. These are small proteins that sit inside of the mitochondria that essentially take some of the energy from things like body fat or from the food that we eat, and instead of turning it into energy that we can use, essentially waste this energy into the environment as heat. Therefore, the thyroid hormone essentially increases the cell's wasting of energy, meaning we need to break down more fats, proteins, and carbohydrates to produce the same amount of energy. This also increases the production of heat within each and every cell, which would increase our body temperature. Thyroid hormones also increase both lipogenesis and lipolysis, meaning they actually increase the breakdown and the buildup of fat. However, the net effect is fat loss. The thyroid hormones stimulate gluconeogenesis, which is the creation of glucose within the liver, and they increase glycogenolysis, which is the breakdown of stored glycogen. This is to generate more free glucose that our cells can uptake and convert into energy. And finally, thyroid hormones stimulate both the synthesis and the degradation of proteins, a process referred to as protein turnover. The way that this would manifest is the following. Patients with hyperthyroidism would typically have very high body temperatures. They would see the loss of both muscle and fat, and have a very difficult time gaining weight. Whereas patients with hypothyroidism would have an easy time gaining weight but a hard time losing weight, and they would feel chronically cold, as well as feel lethargic because they simply are not producing enough cellular energy. And similarly to hyperthyroidism, they would also see a reduction in muscle, because it's important to keep in mind that thyroid hormones are important for the synthesis as well as the degradation of proteins. The thyroid hormone also increases the production of the LDL receptor, specifically in the liver, meaning the thyroid hormone stimulates the uptake of LDL out of the bloodstream, decreasing the levels of LDL within the bloodstream, as well as increasing HDL metabolism, therefore also decreasing the levels of HDL within our bloodstream. Patients with hypothyroidism typically have elevated HDL and elevated LDL, and patients with hyperthyroidism typically have low levels of HDL and LDL. Another site of action is on the heart. The main effect is that the thyroid hormone increases the production of specific proteins, specifically the beta-1 adrenergic receptor, which controls heart rate and blood pressure, which is why patients with hypothyroidism have a decrease in heart rate and a decrease in blood pressure, whereas those with hyperthyroidism have an increase in blood pressure and increase in resting heart rate. Another function of the thyroid hormone is to increase gastrointestinal motility, meaning increase the movement of food through the gastrointestinal tract. Patients with hypothyroidism typically have constipation and a decreased appetite due to food sitting in their gastrointestinal system, whereas patients with hyperthyroidism typically have diarrhea, an increased appetite, and they malabsorb their food, meaning they may be more at risk of nutrient deficiencies. The thyroid hormone can also regulate the production of specific sex steroids, by increasing the uptake of cholesterol out of the bloodstream, which is the precursor for the production of progesterone, testosterone, and estrogen. But importantly, it also increases the production of SHBG by the liver, which is a protein that carries many of these sex steroids throughout the bloodstream. Patients with hypothyroidism typically have low levels of testosterone and SHBG. Patients with hyperthyroidism may see high levels of both testosterone and SHBG. Thyroid hormones also have effect on the kidneys, increasing the blood flow to the kidneys and the rate at which the kidneys filter out waste products. Therefore, patients with hypothyroidism may have a low GFR on blood work, whereas patients with high thyroid may have an elevated GFR. Another marker is serum creatinine, which is filtered by the kidneys. Those with hypothyroidism may have high creatinine, and patients with hyperthyroidism may have low creatinine. The thyroid hormones also appear to be essential for normal brain development, and patients with hypothyroidism may have alterations in memory, language, and cognitive function. With that being said, patients with hyperthyroidism may also develop cognitive abnormalities due to rapidly increasing the rate at which the brain is aging. The thyroid hormones also have a role to play in the immune system, essentially increasing the strength and activity of our immune cells. Patients with hyperthyroidism have a more reactive and activated immune system, whereas patients with hypothyroidism typically have a less active immune system and are more prone to sickness. And the very last thing I'll mention is that the thyroid hormones also control their own production. For example, T3 and T4 can bind to the cells within the hypothalamus and the pituitary gland, responsible for producing TRH and TSH, and stop the further production of TSH and TRH. This is a mechanism by which we do not produce too much of the active thyroid hormones, because the active hormones can actually stop the brain or the pituitary gland from completing the signal to produce more of them. This is called negative feedback inhibition. With that being said, I understand this video is long, but as mentioned at the beginning, this is an extremely complex topic. But hopefully you found one or two new things that you could take away from this video.